So this is CPM Calculus Chapter 2, number 106. So given f of x is equal to 2x plus 1 and g of x is equal to the square root of 3 minus x plus 2, find the inverse function of the inverse function of f, b, the inverse function of g, and c, the inverse function of g composed with the function of f. Okay? So let's start with part A. We know that we're looking now here at the inverse function of f, so we don't care about g for part A. So we're given f of x equals to 2x plus 1. So to find the inverse, we know we start with y equals 2x plus 1, right? This is just like our output y. And then so first we swap x and y. So first we swap x and y, and we get x equals to 2y plus 1, and then we solve for y. Okay, so we subtract 1 from both sides. We get 2y equals to x minus 1. We divide both sides by 2, and we get y is equal to x minus 1 divided by 2. Okay, and that we could write as, we could bring this up as 1/2. And that's 1/2 x minus 1. Okay, and this can be how we answer part A. Okay, so f of x is the inverse of f, right, is 1/2 times x minus 1. Okay, so how do we check this? Remember how to check this is basically by looking at f negative, the inverse function composed with our function of x and our function of f composed with the inverse function of x, right? And if these both equal to each other and equal x, then we know this is correct. So let's just check this really quickly. Our inverse function with the input of f of x is going to be 2x plus 1, right? As the input, we're substituting f of x here. Then we're going to take the inverse function here and have the input be 2x plus 1. So we have 1/2 times, instead of x, we have 2x plus 1, and then we still have the minus 1. So simplifying that, we get 2x plus 1 minus 1 is just 2x, because that's 0. 1/2 times 2 is x. So this so far looks good, because it's equal to x. So let's check this. The function of f composed with the inverse function. So we have f on the outside, and our input is now 1/2 x minus 1. Okay, so the function of f is here. It's 2 times x plus 1. So we have 2 times that input, 1/2 x minus 1, because that's our argument, and we have a plus 1. Okay, so this 2 can be multiplied in, and so that's just 2 over 2, right, when it multiplies by 1, x minus 1 plus 1. 2 over 2 is 1, so 1 distributed doesn't change that. Negative 1 plus 1 is just x. So again, we have verified that this is true. Okay, that's the inverse function of f. So now let's do part B. Okay, part B, we're looking for the inverse function of g. Okay, so here we don't care about f, we're just going to look at g. And so again, we start with this being, so g of x equals square root of x minus 3 plus 2. So we make this a y. And then we exchange x and y. We swap x and y, right? So it's x equals square root of y minus 3 plus 2. And then we solve for x, okay? We solve for y, excuse me. So subtract 2 from both sides. Okay, x minus 2 is equal to the square root of y minus 3. So what do we do now? We square both sides, right? Square both sides, square, square. So we get x minus 2 squared is equal to, well, the square root and the square cancel. And then we add 3 to both sides. And we get x minus 2 squared plus 3 equals to y. Okay, so that right there is our inverse function of g, x minus 2 squared plus 3. Okay? Oops, let me write that again. Equals to x minus 2 squared plus 3. Okay, so how do we check this? Remember, to check it, we have to look at g of the inverse function composed and the inverse function of g composed together, right? We have to make sure that those equal to x. So if this is true, then this is the correct inverse function. Okay, so here, let's start here. And we know g is our output, is our function with the input of the inverse function. So the input is going to be x minus 2 squared plus 3. And then g, we know, is square root of x minus 3 plus 2. So I'm going to put that in here in the square root now. Instead of x, I write x minus 2 squared plus 3. And then it's going to be minus 3 beta. Okay, so minus 3. And then we just simplify that. The minus 3 and the plus 3 cancel out. And we're just left with x minus 2 squared. And then outside the square we have a plus 2. The square root and the squared cancel, so we have x minus 2, okay, plus 2. The minus 2 and the plus 2 cancel, we're left with x. Okay, so then let's check this, because this looks great. So the inverse function of g composed with our function g is equal to our inverse function with the input of g of x. So the input is going to be square root of x plus 3, x minus 3. That's why I always use a pencil, plus 2. Okay, so then plugging this into our inverse function, our inverse function is there. We get that is not our inverse function there. Our inverse function here, we get square root of x minus 3 plus 2, okay, that's x, minus 2 squared plus 3. So we simplify this. 2 minus 2 is 0. Square root of x minus 3 squared is just going to be x minus 3 left. And we have the plus 3. That equals x. So we verified that this is the inverse function of g. Okay. So finally, we can move on and look at part C. So now we want to find the inverse function of g with the input being composed by the function of f. Okay, so that's just, we look at the inside being replaced with our function of f. So that's going to be 2x plus 1. Okay, so the inverse function, remember, was defined here. So instead of x, we have 2x plus 1. Then we have minus 2. And this whole quantity is squared plus 3. Okay, so that's 2x. These join, you can combine like terms. It's minus 1 squared plus 3. Okay, now you can leave it like this, or you can use any method to multiply and distribute 2x minus 1 times 2x minus 1. So that's going to be 4x squared minus 4x plus 1 plus 3. Don't forget the plus 3. And finally, combine like terms, we get 4x squared minus 4x plus 4. Okay? So this right here is the inverse function of g composed with f. Okay, you can have it like that, or you could box it right here. Alright, so this ends CPM Calculus Chapter 2, number 106.